test, the definition here is written down for you. So let f be a function such that the derivative at some point c equals 0 and the second derivative of the function exists on an open interval containing c. Okay, so the derivative must exist and the derivative must equal, sorry, the second derivative must exist and the derivative must equal 0. If all that holds true, and when you apply or when you input c into the second derivative, you get a positive number. That's going to imply you have a relative minimum, because think about what that means. If our second derivative is positive, that implies you have a concave up shape. If you have a concave up shape, that means it has a valley, a bottom. That would be the relative min. And likewise, if your second derivative is negative, that implies you have a concave down situation, which implies you have a peak or a relative max. All right, and of course, if the second derivative equals 0, well, you don't have any concavity there. The test fails. It tells you nothing. It could be relative min. It could be relative max. It could be neither. Okay, so you need to go back and use the first derivative test. So let's take a look at this in action here. It's taking big jumps today there. Okay, and now it's freezing. All right, let's go back up here. So let's look at a polynomial function. Let's just take negative 3x to the fifth plus 5x cubed. And let's determine our relative extrema using the second derivative test. So first derivative is negative 15x to the fourth plus 15x squared. Okay, so keep in mind what the second derivative test says. It says that let f be a function such that f prime equals 0. So I need to set the first derivative equal to 0. I'm going to factor out, what do you say, a negative 15x squared. And I'm left with x squared minus 1 equals 0. So I get three solutions, 0 and plus and minus 1. So let's check this definition out. F prime of c equals 0. Check. And the second derivative of f exists on open interval. Well, I can certainly take a second derivative. If the second derivative at c is greater than 0, and if the second derivative at c is less than 0, we have relative extrema. So let's take the second derivative. F prime of x, I'm looking up here now, is negative 60x cubed plus 30x. I have three c values to test. F prime of, we'll take the easy one, of 0 equals 0. Okay, the test fails. That tells us nothing. F double prime of negative 1. Well, if I plug a negative 1 in to here, I'm going to get a negative and a negative. So that's 60 and negative 30. So I'm looking at positive. F prime of negative 1 is a positive 30, okay, which is positive, which implies I have a relative min because I'm concave up. My c value is down here at the bottom. And the second derivative evaluated at 1, it looks like we're going to get negative 60 plus 30 is negative 30. That is a relative max because we're concave down, which means I'm at the top of there. Okay, and specifically it'll be negative 1, comma. If I put a negative 1 in here, I get 3 minus 5, right? So it would be negative 2. And if I plug a 1 in up here, I get negative 3 plus 5, so I get 2. And this point where it failed at was 0, 0. Okay, so since that failed for us there, let's see how we deal with that. It says up here in the definition that if it fails, we need to use the first derivative test. So the first derivative test, I'm looking up here, and specifically I'm concerned with 0. So I'm going to look at, I have all these intervals from negative infinity to negative 1. I have negative 1 to 0, 0 to 1, and 1 to infinity, right? From all these guys, there's my intervals. The ones I care about, though, are the ones surrounding 0. Okay? So a test point would be like x equals negative 1/2 and x equals 1/2 for this interval. So if I put a negative 1/2 into my first derivative, I'm going to get a positive times a negative is a negative. And here I get 1/4 minus 1. So negative and negative makes a positive. That tells me my function is increasing, right? It's going up. If I put in 1/2, I get a negative times a negative, which again is positive. Okay? So it is also increasing in that direction, increasing. So if it's increasing in both directions, on the left side and the right side there, 0, 0 is neither a relative minimum or a relative maximum, even though it has a horizontal tangent line at this point. Okay? So it is not a relative extreme at all. It could be a situation like this. Come into 0, 0, and go back out. That is not a relative extreme, increasing going in, increasing coming out. Okay? So that's something that certainly could happen there. Okay, so that is the second derivative test for you there in a nutshell. Hope you enjoyed it.